2. Welcome to Precalculus. Today's date is Tuesday, January 12th, 1/12/2021. Yeah, we're making invertible functions by restricting the domain. So our objective today, make sure everyone has their cameras on, please. What is our objective? Quite raise hand. No one wants to read the objective. Leo, yes, thank you.
Okay, determine if a function is invertible, and if not, make it invertible by restricting the domain.
There it is. So there's 2 assignments that you have. The first assignment, which should take you about a minute in total to do all 4 problems, is just figuring out if a function is invertible. Actually, it takes a little bit longer than that because you have to like drag things around. But immediately, just from a table, you should be able to tell if something is invertible. And then restricting the domain, that is a little bit more tricky, and I'll talk about that hopefully a little bit more than the first one. Okay, so let me talk about all the way back to Algebra 1 when I talk about if a function is a function. Is this line a function? Is this curve a function? How do you know? And it's the vertical line test. So here's in words what I'm about to say. A graph is a function if it passes the vertical line test, because it only has one output for every one input, one y value for every one x value. The vertical line test is a way to assess that you only have one output for every one input. So let's practice with example 1. If I just go ahead and draw a circle, is that a function? Well, I can represent that with an equation. Just because I have an equation doesn't mean it's a function though. This equation is x squared plus y squared is equal to 9. But is it a function? Well, if you draw a line, a vertical line going up and down, just like basically anywhere, you'll see, hey, this hits the function twice. It is not a function. The answer here is no. This is not a function because it fails the vertical line test. The vertical line test states no matter where I drag this line, this green line here, no matter where I drag it throughout the entire function, it should never touch the curve twice. It should never touch it more than once. And look, it touches more than once here, so it fails. It is not a function. Okay, and then you can do the same thing. Let me just I'm gonna be lazy, copy paste. I'm gonna grab another vertical line. No matter where I drag this vertical line, I should only touch once. And you can see for the second example, yeah, it only touches once. This is a function. And you know this equation as well. The equation is just x squared, probably minus 2. I'm guessing it got shifted down. This one passes. So this one, yes, it is a function. It passed the vertical line test. It only touches the function once, no matter where I drag that vertical line. And again, you kind of do the same thing. You drag that line over here. Does it touch more than once? And yeah, most of the time it touches more than once. Like over here, it touches twice. So this is not a function. It touches once, twice. So the answer here is no, this is not a function. It touches twice. The whole point is, here are my instructions. My instructions for you, Sam, is x is 1. The x value is 1. You're going to give me only one output. What is the output over here? And you're like, oh, shoot, I don't know. Do I decide between negative 1.7 or positive 1.7? I don't know. What does Mr. Snell want? That's the point. There's 2 outputs. You don't know what output you should give. There should be only one output for every input that I give you. I'm about to flip this on its head in a sec, so make sure you have this solid understanding. There should only be one y value, only one output for every one input. It can't fail the vertical line test. Vertical line test can only touch the curve, the line, whatever it is, one time. Okay, it feels like I'm kicking a dead horse. That's a good thing because you have a solid understanding. Okay, I'm inverting this. I'm flipping this on its head. I'm going to talk about invertible functions. If you invert a function, that just means you switch the input with the output. You trade those. In fact, to make an invertible function, you literally switch the x and the y, and then you resolve for y. It's a way to make an invertible function. But literally, you just switch input with the output. And there's a lot of synonyms. Another way to say this, you could switch the x with the y, right? X and y. X was the input, y was the output. Or maybe I can say domain and range. That's what Khan Academy loves using. They love using the words domain, and range. The range is all of the possible y's. The domain is all of the possible x's. We'll talk about domain and range maybe in a future unit. It doesn't really come up too much this unit. All right, so from this definition of what it means to invert a function, two really important things, especially for the homework tonight, come out of that. The first homework assignment is this. The function and invertible functions, they only have one input for every one output, which is the opposite of what I said at the very beginning. Look up here what I said at the very beginning. Let me maybe zoom out so you can see them both at the same time. At the very beginning, I said you only have one output for every one input. Now it's one input for every one output. Remember I'm gonna pick on Sam a little bit. Remember Sam's dilemma of, I told her, you have to pick, or I chose 2 on this graph. You tell me the output. Well, that's easy. The answer is just 2. Or if I choose 2 on this graph, you should be able to tell me what is the output. And you're like, oh no, I don't know what to choose. Do I choose that point or that point? I don't know what to choose. That was our dilemma. If we have 2 outputs for every one input. Now it's flipped on its head. Now I'm looking at the output, and that'll be made clear in an example. So let's go ahead and make this domain have 4 points and this range have 4 points. So if the domain looks like this, where it goes, this point goes here, this point goes here, this point goes here, and this point comes down here. Let me make lines so that it looks a little bit nicer. Maybe this is what my function looks like. This is a different way of representing what's happening instead of a graph. It's a more simplistic way of doing it. Check it out. It's okay as a function. This is a function. Why? Because this one input, I know where it goes. It goes right here. This one input is fine. I know it goes here. This one input is fine. I know it goes here. This one input is fine. It goes here. What would not be a function would be if I had something like this. If I had this one input went to 2 different outputs. This is a bad thing. This is now no longer a function, because if I tell you, hey, start at that point, you don't know what to tell me. Well, do I go to this one or do I go to this one? You're scratching your head. I don't know, because it goes to 2 different places. So this is not a function. Now it is a function. If I take away that line, every single point, I know where it's going to land. I know the output value. So this function right here is a function, but the problem is this is not invertible. Let me label this one. This one is not invertible. Invertible. Why? Switch it. Switch the range with the domain. Now, if I look at this point in the range and I say, well, where does it go to in the domain? And it goes to that one point. Okay, no problem, no dilemma. If I look at this point, yes, no problem, no dilemma. It goes to that one spot. The problem is this point right here. If I say, hey, start at that point in the range, where does it go to? You're scratching your head like, it goes to one of these 2 points. I don't know which one. And that's the problem. In order to be invertible, you cannot have 2 things in the domain going to the same thing in the range. So when you're doing the homework tonight, I can simplify this as much as possible. If you see anything connecting twice over here in the range, it's not invertible. End of story, the end. That's how to do the homework. Well, Mr. Snell, what would be something that is invertible? Let's give you a second scenario. This one is going to be yes. Yes, it is invertible. Something that looks like this, and I'm going to kind of skip the dots altogether and just do lines. If I had something that went like this, every single thing over here, if I go backwards, this point, back to this point, I don't have a dilemma. It already goes to 1 point in the domain. This point in the range goes to 1 point in the domain. This point in the range goes to 1 point in the domain. This point in the range goes to 1 point in the domain. There's no confusion over what point in the range should map back to what point in the domain. So that's the analysis of the domain and range to say, am I invertible or am I not invertible? But there's a graphical way to represent that as well. So this is the first definition in the first homework assignment. There's a second definition in the second homework assignment that also comes out of that. Graphically, In order to be a function, you have to pass the vertical line test. Graphically, to be invertible, today's lesson, you have to pass the horizontal line test. So let me write the word horizontal in here. If a function does not pass the horizontal line test, it is not invertible, which means if I come back up here, this function right here, this x squared, this is not invertible because this horizontal line touches it twice and it can only touch once. So very much like the vertical line test that determines if it's a function, the horizontal line test determines if it is invertible. Let's put this to the test. These are examples that look almost exactly like your homework. One homework assignment in example 2, one homework assignment in example 3. In example 2, it says, okay, we have a function, blah, blah, blah. This is our function. A goes to 1, B goes to 2, C goes to 3, C goes to 2. And it's asking, is the function invertible? What you have to do first is you have to actually draw the lines. Okay, if I start at A goes to, it says A should go to 1, A goes to 1, boom. Okay, where does B go to? B maps to 2. You draw that line. C maps to 2. Okay, that's the first step in your homework. Whew. That was hard, right? Hard work. Map where what goes to what. Next, you answer the question, is it invertible? And this is where I need you guys to finally participate because I've been speaking for way too long. I'm sorry. Oscar.
No,
You're correct. Why?
because they all don't have their own point.
Yeah, I think I understand what you're saying.
Is that what Mike said?
Yeah. What do you mean they all don't have their own point?
Like they share 2 together?
Yeah, B and C, they share 2, which means if I went backwards from 2, I wouldn't know to go to B or to C. I have more than one output for, so this output has 2 inputs. I can only have 1 input for every 1 output. Yeah. So give yourself a pat on the back if you understand that. And even better, give me a fist of 5. How well do you understand Oscar's answer? How well do you understand example 2? Yes, I'm getting high 4s, high 5s. Looks like you have the understanding. That's awesome. You understand invertibility at this basic level. Let's try to advance that level a little bit. Let's do example 3. A little bit harder, I'm warning you. Okay, here's a function graph below, it's f. And I'm already telling you it's not invertible. Why? Because it doesn't pass the horizontal line test. And it's pretty easy to see that right away. It's already telling us, hey, if I drag this line somewhere, look, it's gonna hit twice. It's gonna hit twice, no, almost anywhere that I drag this line. But remember, the horizontal line test says if it passes through this line twice anywhere, at any one point, it fails. And it fails at multiple places here. It fails here, I can drag it up here. It super fails right there. Look, it hits 1, 2, 3, 4, 5 times at this spot. And up here, yeah, okay, it hits twice, but it still fails the horizontal line test. So it's saying, hey, let's try to actually make this an invertible function. Let's make it past the horizontal line test by restricting the domain. What that means is between what x value and what x value will it pass the horizontal line test? And there usually are multiple answers here. Let me give you one. And I'm going to give my range in inequality notation. So I'm going to say x is between these 2 values. If I chose, I don't know, between 2 and 5, so between 2 and 5, that would make it invertible because between these 2 lines, the horizontal line test will make this function pass. No matter where I draw this horizontal line, in this interval, it will only touch the line once, only if I restrict the domain between 2 and 5. Can anyone else make me pass the horizontal line test with a different domain? I'll go ahead and write the hard part for you. The x is between certain points. Between what and what point will also make you pass the horizontal line test. That will make it invertible. Yeah, Ellery.
5.5 and 7.5.
That's right, 5.5 and 7.5. So 5.5 is right here and 7, wait, that's 4.5, sorry. 5.5 is right here. 5.5 is it looks like it's at the maximum of this function, and 7.5 is somewhere over there. Yeah, between these two orange lines, there's no way for this to fail the horizontal line test. Perfect. That is another answer. Someone else give me another one. Give me another range. We'll do this one in green. Yeah, Beverly.
-5 and -3.
-5 and -3. So -5 looks to be right about there. -3 looks right about there. Yeah, exactly. This little line segment right here, this curve, there's no way for this to fail the horizontal line test because I've restricted the domain to just look at that piece. Perfect. And there are technically an infinite number of these intervals. So on Khan Academy, I think the problems are stated like as a multiple choice. The student found like these 4 or 5 intervals. Which of them are actually correct that make it invertible? That's the type of question we'll be asking. So give me a fist of 5 on example 3. It's the hardest level question that I can ask you. Oh my God, I got a 5 already. A 4? A 4? Oh my God, you guys are killing it. 5, 4 from Leo. Okay, 5 from Beverly. That's awesome, guys. Okay, well, you have it then. That's how you do the homework. You're going to restrict the domain to make it invertible and check if it's invertible by just looking at the domain and range and how points map onto each other. And map is a fancy word of saying connect the line. All right, good job, guys. I will upload these notes to our Google Slides, and there should be 2 homework assignments that are already up on Khan Academy. Let's do that. You basically gave me fist of 5 already. I know that your fist of 5 is going to be 4 or 5 for our entire objective. So we're good for that. And that concludes the notes.